So let's talk about how do fields behave, because it's not, again, it's not rocket science. If I've got a sphere made out of metal, and there's a conductor in the middle, and there's charge in the space between the surfaces, because field lives in space. If there's not a hole in the sphere, there's no way for the field that's inside of the sphere, in the space between the two conductors, can go out through that, because fields don't travel through conductors. They travel through space, whatever that might be. Dielectric on a circuit board, air, anything that's not a conductor. And if there wasn't a conductor in the middle of this, you can't store field in a space that's not bounded on both sides by conductors. So to have field present and managed, you need three things. Two conductors separated by a dielectric. In this case, one of the conductors is a complete sphere. The other one's just a piece of copper in the middle. If there's a hole in the outside conductor, and there's another conductor anywhere in the universe, there will be shared field between those two surfaces. So between the outer surface of the inside conductor and the outer surface of the outside, the space conductor, there is going to be shared field energy. Between that inner conductor and wires in the wall, there will be shared energy. Between that conductor and satellites in orbit, there will be shared energy. Because Maxwell's equations and the laws of physics say that between any and every pair of conductors, if there's any field at all, they will share the field. So think about a printed circuit board. Thousands of conductors, and all of them, and hundreds of signals. Every one of those signals is being shared with another conductor in a different space. The only reason things work at all is because the magnitude of that field is reduced by the square of the distance. So we got problems with crosstalk. You move stuff apart. It's because when you move things apart, the amount of energy that's between those two conductors has been reduced by a square factor of that distance increase. But there's still field everywhere. We're surrounded and completely engulfed by field. On a circuit board, we're building these pathways for the energy out of a bunch of leaky water pipes. And all of the energy is doing its best to go everywhere. So what we're forced to do is to try to find a way to get enough of the energy to go from the space where it's stored to where we want it to be without it losing any type of value, whether it be information or a voltage driving something. We need to get enough of it over there to still be coherent with the purpose and not to have messed up all the signals around it, which is a pretty daunting challenge.